So I woke up this morning and I had no voice. It's not the best timing. I like to interact a bit with the participants in a talk. I don't like the word audience for that reason. I like participants. Because of the voice, please help me, speak up. And thank you for coming to talk a little bit about Git. So, what is this talk? I like to call it a show and tell, okay? It's a few slightly advanced operations, and some of the steps I make every day to enable those, and how I integrate Git as a part of my developer toolkit along with my compiler and editor and brain. I'm going to focus largely on what you can achieve with Git more than as a sync. And it's a very quick primer on how to craft commit to set you up for success. So, but first a show of hands, please. So who uses Git? It's a pretty overwhelming. Who doesn't use Git? Yes. Do you have a version control system that you use?
Yeah. We have the older projects use TFS.
So, Madam here uses TFS. So,
Wait.
okay.
We have projects that use TFS or Git.
TFS or Git.
Right now, I'm on Git.
You're on TFS. Okay, so for that, I'm going to give you a treat. I think you need it. It's right before lunch, so if you're a little bit snacky, if you say something smart or funny or interesting, you will get a treat. It's very Pavlovian. So what is this talk not? It's not a deep dive into the internals. We won't be discussing objects or blobs or really complicated, or sort of the bits and pieces that build Git fundamentally from a sort of implementation point of view. And it's not a tour of the dark corners of Git. We're going to focus on the high-level stuff that you will interact with as a developer, and that actually fits into the model that Git presents to you. It's not an introduction to version control systems. So if you're here for that or for a big rant, then unfortunately this talk is not for you. I'm sorry. So okay, I would like to preface the rest of the talk with that I do all of these things. I would say every day, but that wouldn't be true. Most days. And I do it even in single-person projects. So one notable thing here is that we're actually never going to push. We're never getting to the point where we're actually pushing changes. Because quite frankly, the synchronization bits of Git are the least interesting to me. This is what version control can look like. I've seen uses of Git which essentially disintegrates into that. This is what we try to avoid. This should be model.c or something. Okay. Almost everything I'm going to show doesn't necessarily require good habits, but if you have good habits when you're interacting with Git and you're pushing Git earlier in your workflow than right at the end before you're going to push to GitHub or something, it just makes everything easier. And of course, you don't have to take my word for it. You have to take Chris' word for it. And he writes in a very good post that I encourage you all to read, is that a well-cared-for log is a very beautiful and useful thing. Git blame, revert, rebase, log and short log, and all the other subcommands, they come to life. And I remember being struck by that, because it's a very poetic way of saying it, but they do really come to life, provided you care for your log. So when I say 5072, who knows what I'm talking about? Okay, so I see maybe 5, 10 hands. Okay, would you mind answering?
Well, 50 is the length of the first message.
The subject. So 50 is the length of the subject. It's a very good attempt. It's not true. It's 0.7, approximately. But it's good enough to warrant a snack. There you go, sir.
Thank you.
All right. He's, of course, absolutely right. It's the convention of limiting the subject to maximum 50 characters and to limit the line length of the message body to 72. This, at the face of it, kind of seems like a pointless exercise. And I hear all sorts of arguments for why these limits shouldn't be in place. Sometimes you need more. Okay, fair. We have big monitors. I suppose. I mean, I don't, but I suppose. But this is what happens if you don't limit the lines. Who thinks the seconds is easier to read? It's a remarkably... Oh, one, yes. A contrarian, I like it. Of course, we lose information here because it bleeds outside of the page, right? Git does not wrap messages in any way. And it's important to note that even though you might have a big monitor and have reserved a lot of space for this, it's very possible that your reader does not. Excuse me. Now, 5072 is not just useful to deal with the big monitor problem. And even outside of that, the subject in particular is used for a lot. So when you do git-log one line, or anything else that prints or shows the log in a sort of one-line configuration, they will only show the subject. So, quick show of hand, who uses VS Code for Git? It's about a third, maybe. Okay, IntelliJ or similar IDEs. It's a different third. Who uses the command line? Show of hands. So there's a significant overlap over the two previous groups in this one. Okay. Those who don't use the command line or use the git log through the VS Code. How much space do you give the git log on your screen? Yeah, that's a good one. Okay, so he did this. It's a snack right there. Here you go. Pardon. Okay. Even though your monitor is big, it's quite possible that the window that you will actually give Git is not big. It's more likely than not. And if the subjects become very long, and then it's very hard, or you lose information because you truncate, right? And what you want to do is you want to put more information into the characters that you do have. Now 50 is a good trade-off between how long it is and how easy it is to render. And what I find as a bonus is that it forces you to focus your content a lot. So you aren't able to use more words to say less because you don't have more words. You have 50 characters. So use them well. The subject is also added after verbs like revert. So Git's auto messages will use the subject. The 5072 are arbitrary, but they're not. They're kind of well-founded. 80 is the typical size of the default size for a lot of typesetting. It's the default size for email, which we agreed upon since sometime in the 60s, maybe. And this really comes from email because a lot of, Git was developed for Linux, right? And they develop on the email. So when they reply to things, it will be quotation, which means indentation. And just to have room for a few, you make room for 4. And for symmetry, you make room for 4 more. So 4 on each side. Turns out that's a pretty common or appropriately sized number for a lot of other typography reasons. So I think it's a pretty good default. If you really want to, you can put it at 80, you can put it at 100. But please don't make your lines, 1,000. Tim Pope in 2008, which is honestly not really showing his age, wrote about this. So I recommend you read his post on it. I find that formatting the subject in particular in an imperative format changes the context on which you consider what a commit is. It's kind of a transformation or a function you apply onto your code base, onto your tree, right? And it just changes that little bit of context, which is very valuable to me. The imperative make it like a command, so you have your add, remove, fix. Fix is something you have to be careful about, because fix can very quickly deteriorate into a nothing word. Handle can sometimes be a good one. This is honestly a guideline. I prefer that. You do what works for you and your team. But I like to be able to answer the question, if I apply this commit, what will happen? So if I read a commit message, I shouldn't really need to read the diff to realize or to have a pretty good idea on what the contents of the code changes are. I should be able to get that up from the message. So what you want to do, what your goal is when you're writing a message, is to answer the questions such as, will this commit, or if applied, then this commit will refactor the subsystem, or it will update some documentation, or it would kill some deprecated methods. It could release something. Like, what question would the reader want answered for this? Note the last one, merge pull request 1, 2, 3 from user branch is what Git automatically writes, so it's symmetric with that. Now, in writing messages, so who spends more than 10 seconds on writing messages? Okay, so about half. Who lied just now? On occasion. Okay, so honesty gives you a snack. On occasion. Good. That's a good habit. Spend some time at the end of a commit to sort of capture the answers to these questions. Why should whoever is considering to apply this commit to their tree actually care, and why would they want to do it? And you do that by not repeating what the code does, because the code is pretty good at explaining or doing what it does. Hopefully, sometimes. But you should focus on the how and on the why. With the emphasis should actually be on the why. But now you have an opportunity, because the message body is in free form. This is an email. So now you can write whatever you want. You can summarize research. You can say what you tried, but that didn't work, which is very good, because now I know why it is written in a particular way. You can add references, you can summarize your decisions, right? Let me know why I should care and what you're trying to achieve here. And this is particularly important if you're going to do spelunking, if you're going to go back and look at the log, because knowing why a change was made is often crucial to understanding if it was correct, if there was a bug, or if there was some other motivation, or if something is missing, or what drives the code base in a certain direction. Since this is free form, we actually have the opportunity to do cool things. You can add tables and links. You can add lists, code listings. You can reference tickets. And you can even include parts of other commit messages. So I have done that on occasion. It is very useful to contextualize why a change is happening. So who here does the commit message where the thing you're doing is you're referencing the issue in Jira or GitHub or... Okay. So maybe 80%? How much more information than the ticket number do you add, usually? Anyone have anything in particular? Okay, so who then uses just the ticket number? Honesty, but you already got a snack, sorry. That's one, okay. Do you mind telling us why? Do you need anything more? That is a good question. So who here has had an issue tracker and then later the company moved to another issue tracker? Do you need anything more? No, it keeps going no. Okay, so for that honesty, you get a snack. Where's the speaker? I need to toss, sorry. Very good. What I like to do is I actually like to copy the interesting bits from the issue tracker into the commit message instead. Because the git log will persist and links and references and servers might die. So actually, I have a cool demonstration, personally, I think, from GCC, where adding cool things to a message, really helps. So it's here. Maybe you even remember this message. It's the one that overflowed before, but I had to break it because he actually wraps it properly. So what it does isn't actually so important for this, but it gives you a lot of context. So I'm going to read just a few key bits. So this patch implements another of Uros's suggestion to investigate a ins VTI low part 1 pattern to improve TI mode parameter passing on x86-64. Who got that? No, you didn't. I didn't. Well, maybe you did, actually. I'm sorry. I did not at all. But that's OK, because this message isn't for me. It's for the other people working on that subsystem. We humans are blessed with a superior ability to work with context. And in this case, the context is we're working on this specific subsystem on i386 in GCC. So it's reasonable to assume that whoever reads this knows what ins VTI, which is probably some instruction thing, low part 1 pattern, right, actually means. So this is not gibberish if you're in the domain. So it implements the suggestion. Then it adds a low part 1 pattern complementing the existing high part pattern, and also a 30-bit variant. But what is cool is, in this message, he actually includes a tiny, tiny code snippet, 4 lines, and the assembly that pops out for 64-bit and 32-bit for comparison. So I don't know if you read much assembly. If you don't, that's perfectly fine, but I'm sure you can appreciate how obvious this makes the motivation for the patch and how valuable that is when I'm looking at this patch and thinking, what actually changed? What deeply changed by applying this commit? And Roger here tells us. It's fantastic. So I really like this one as that example. OK, so if you wouldn't mind being completely honest with me, who here does the thing where they write a bunch of stuff? You do git add, maybe dot, and commit and push. All right, so you were the first one, and this is about the third. First one gets a snack. It's very good. Follow up to that, this is not a snack question, but follow up to that is, how often does that make a focused commit? How is that sort of hyper minimal to the problem you're solving? 20% of the time. Sometimes, right? So what inevitably happens, if that is your workflow, your commits will be kind of messy. They might kind of bring in different flavors of changes at the same time. Those commits are harder to work with. Focus commits that do one thing and then, they're easier to understand, they're easier to review, they're easier to cherry pick, they're easier to understand in log, they're easier to appreciate the context and the problem that they're actually for. They're also easier to work with when you need to verify that they compile and pass tests. Now, public history is immutable. But public history is sort of a convention thing more than anything. So who here has a master branch in their tree somewhere? I think that's everyone. OK. Have you ever had the case where your local master branch has been deeply out of sync with the master to the point where you needed to throw away one of the copies? There are some nods there saying, wait, who said it? Did you say yes? Okay, that's a snack right there. There you go. Do you mind telling us why?
I was working on 2 different computers, and one of them I had been using one solely for a long time,
Right.
whereas the other one then had been so far behind that when I tried to fix it up or like pull it, it just didn't. I got
Okay.
conflicts and
So you worked with 2 computers. One of them had become so far behind that by the time you tried to sync them, something was wrong. There was an inconsistency, right?
Yeah.
So that is actually a good example of when what has happened is that they had 2 different ideas on what was public and by extension immutable. And so it couldn't resolve. And this is one of the reasons why you generally shouldn't rewrite history, right? History it's written by the committers, but once it is written, Git is very much an append-only system. But what is public is up for debate, right? So every project has a convention, either implicit or not, on what is public, right? Usually that means whatever is called master on the shared GitHub instance or GitLab instance or Bitbucket or whatever other system. Sometimes it's whatever is on that guy's computer, which is incidentally how Linux works. Like whatever is on Linux's machine, that's the truth. Everything else is up for debate. You can build on other people's histories even if they aren't totally public yet, but at that point you have maybe a race condition, because if they choose to edit that a little bit, you can't keep on building upon the same thing without resolving those changes. So keeping public history immutable is very useful. So the question is, how do we get to the point where we make our commits focused? And my favorite approach is to git stage. Git stage is a part of, it's probably the first hurdle in Git for new users, because you kind of expect add and commit to be the same thing. So who did that, honestly, when they started out with Git? Okay, very good. 4 or 5 people, maybe, who immediately grasped the stage. I would have expected a lot of hands right about now. Okay, before I go on, I have been using Git for a while. Stage, index, cache, all mean the same thing. And I might end up using them a little bit interchangeably, I apologize. They all mean the same thing. So in Git, changes are staged before they're actually committed, in which case the stage is closed off, it's annotated with a message, and it becomes permanent and an atom in the Git model. This is actually very nice because it means that staging is no longer at sort of change or at file resolution, it is a change resolution. And that means you can have changes on your file system that don't become a part of a commit, which is one of the ways I focus my work, if you will. If you use the command line, the driver for this is add patch. In my opinion, this should be the default behavior. The sort of hammer approach of git add or git add file, in my opinion, not high enough resolution. I almost never want the full file add, I always want the patch. Have anyone of you actually used the patch before from the command line in this case? Okay, so maybe 10 hands. Have you used patch-like functionality where you stage parts of the file but from your VS Code or IntelliJ something? So, okay. And the rest of you presumably just adds whole files. I see some notes. There's a yes. Good. I was hoping for a comment, but a yes is good enough. All right, snack. Could you pass it to the gentleman in the back? Thanks very much. I'm a bit terrified for running up again now to not get the feedback. So patch mode is brilliant. So what I'm going to do now is I'm going to go to GCC, the compiler. This is the, hang on. Updating files. So this commit by Alexander is the last one that was made. What I'm going to do is I'm going to undo that commit. And then I'm going to stage his changes one by one, but I'm going to pretend I wrote it. And I'm going to only do a subset of his changes. So now, if we do git status, oh, pardon, let's actually do filter it. If we now do git status, you see this commit had 4 changes in it in tm.texi, which is the documentation format that GCC uses. 1 change to a file called dwarf to out, and 1 to a file called target.def. Now what we want to do is that we want to not add the documentation stuff, because documentation is for losers. We're going to add parts of the dwarf file, and we're going to add all of the target file. In my opinion, this workflow right here is brilliant, because Git knows what has changed and not, right? So I don't actually have to go into the file and then look for those changes like you might need to do with a scroll wheel and a mouse. Instead, Git will present me with the changes it knows about and ask me, do you want this, yes or no? So we do add patch, and it presents me with the patch in tm.texy. And now I get a final chance before actually staging something and creating a commit to check, do I actually want this in this commit? No. Documentation is for later. So I say no. This too is for the manual. No, don't want that. Oh, this one. I honestly don't know what this does. I have no idea. But we want it. So we say yes. We want this. Sure. We also want this. Another yes. And it's very common, it's quite common, that you want most of the file. But it's good to have a final check. Am I actually committing what I think I am committing, or did I accidentally change a white space here or rename something there that is actually meant for later? Yep, let's skip that one. Oh, okay, so this one is good. Here we have a loop and this call our lock note thing. And what we want is we want the we don't want the loop, but we want the function call and assignment. Okay? So what we can do is that we can split it, and Git will try and break down the hunk even more. Git calls these clusters of changes hunks. Okay, so we want this, but we do not want this. So yes and no. And finally, let's bring in this as well for good measure. But we don't want the hook stuff. That's for later. Okay, so if I do git status again, you will now see that we have some changes in GCC dwarf to out that are staged, and some that are not. So a file is both staged and unstaged at the same time. And this is because Git tracks contents, not files. The resolution is higher than just a file. It knows that it has modifications that it hasn't staged. Okay, so we commit this, and now I'm going to kind of do a sin, I suppose. Add some stuff to dwarf. A very good message. And then I'm going to write it, and now we have a commit, right? So here we have a proper commit. And if we look at the status, we now have the texy stuff. Okay, so let's actually bring that in as well. Yep, and I always do this, where even if I just went through this whole staging thing, I still make another check to make sure I don't get anything more than I wanted to. We want that, but here in this case, if you use the command line and you press write question mark, it will tell you what the commands are. I don't have to ask it anymore because I've been doing this for a decade. But when you're getting used to it, this is a pretty good thing to do regularly. Okay, so we don't want anything more in this file. Because let's pretend that was debug code. We had some printfs that we didn't want to commit. But we do want this def hook. Okay. Add some docs and a hook. Right, good message. Not really, but... And now... we only have changes left here. And we started out with changes in 4 files. Now we have 2 commits, and we still have some unstaged changes. But let's pretend that's debugging code that we don't really need for committing. We just can throw it out. I didn't have to manually go through my editor in that file to weed out those, to not commit them. And this is a way of getting hyper-focused commits. Just don't stage all of it. Increase the resolution of the changes you are staging. Okay, hard upstream master. Okay. Reset works the same way. If you stage something that you didn't intend to, you can reset all of it, or you can reset parts of it. It has the same interface, and we're not going to demo it now. But I recommend you try that. Honestly, this experience is usually pretty good in the VS Codes and the Emacs, because you can do it sort of visually in the hunk in your editor, where you already have the file up and you have the blocks, right? Oh, sorry. What you also can do is you can reset not just what would be staged or unstaged, but you can reset parts of the previous commits, and this will actually remove it from that commit and make it unstaged into your tree. So if you stage something you didn't mean to, if you add something you didn't mean to, and then you commit, and you go like, shoots, I should have split this into 2, this you can do. And when you push this, no one can tell that this has happened. They just see the commits, as if you're perfect on the first try. I'm never perfect on the first try. Likewise, you can check out a file with the same patch mode. So what you do here is you grab some earlier revision. In this case, it's head, but it could even be earlier. And you check out changes from that file one by one. I actually did this once for work. So I had a file that I knew I deleted 4 months ago, something like that. And I wanted to check out what I was doing in that file, because I wanted parts of that back into the new approach, which was very different. But I wanted to keep that up for reference for a while, right? So I needed to have them side by side. Now, this bootstrap directory was long gone, but I just checked out the file from there and had it back into my tree, but now not as a part of a commit. Open it in the editor and copied out bits and pieces that I needed, massaged them a bit, because Git knew it was there. And I could just fetch that one file from the log. Now, in this case, I even just got the subset of the files that was there before the directory was deleted. So this was very precise, but thankfully, this commit too didn't do anything more than just kill that directory. This is very useful. Okay, so now that you have some laser-focused commits, we need some tools to work with histories. Now, I don't know how much you do this. We're going to see a demonstration, which will be cool. One thing is the cherry pick. So who has used the cherry pick in their life? Okay, lovely. Anyone have a good story of why? Why did you cherry pick?
It was like 2 different.
Sorry, but
Moving a bug fix from a later patch version into the...
lovely. So he moved a bug fix from a later patched version into a release branch, presumably.
Yeah.
Lovely. That's a snack right there. So you already had one. Sorry.
It's something about the snacks.
Oh, is it? Oh, not about the snacks. Here you go, sir.
Thank you.
Cherry pick is fantastic. It allows you to just take the changes that a commit applied and splice it onto a different tree, and there doesn't really have to be any strong relationship between them. Who here merges changes by hand? 1. Okay, and the rest of you, I presumably use the GitHub Bitbucket kind of merge. Do you have a?
I'm just doing. I do it by hand.
You do it by hand. Lovely. That's a snack right there. Everyone should merge by hand once in a while. It's a good skill to have. Presumably, maybe I'm getting ahead of myself, but presumably you don't merge by hand because that way, well, one, you don't go through the interface and you paid a lot for GitHub. And two, that means that occasionally there will be conflicts you need to resolve. And we tend to build processes to avoid conflicts rather than resolving them. Now, notice that the merge here has 3 dots. Anyone know why? That is something called the octopus merge or the Cthulhu merge, depending. I recommend you look into that, but in Git, it is perfectly possible for a parent to have more than, or sorry, for a commit to have more than 2 parents. It can have multiple, and Git handles that just fine. It gives you that extra little bit of a kick where you can choose to merge everything or nothing in case there is a conflict, or resolve all of the problems at once rather than sort of stepwise. It's occasionally useful. Most of the time it's a curiosity. Git rebase. Who has used Git rebase? Lovely. That is pretty much all of you. Who has used rebase as an alternative to merge? It's 50-50 overlap. And then who has used Git rebase to tune their commits before they do the pull request? It's, what is that? Maybe a third. Okay, so Git rebase is, today the word is a bit unfortunate because it both means the driver program that you use to rewrite histories. It also means as an alternative to merge, I suppose. I think the latter is unfortunate. And maybe we should pick up a better word for that. But I personally use rebase, all the time. I use rebase to drive something colloquially called squashing, where I merge 2 commits that I have made at separate points in time into a single commit because they weren't separate in the first place. I also done it to undo a squash, 2 things that I wanted to split up by using edit and then reset. I also use it to run tests, which we'll see. It's pretty cool. So I am going to break this history by bumping the version tag 1910 in and merging it into the build Python 3.11. They're completely unrelated, and it's a good thing that they're separate, but for the exercise. The rebase is driven by, well, actually, it's just a relative. It has an interactive mode, which is in true Git fashion, gives you a text file you need to edit, which becomes kind of a program. By taking some, and you give it a reference, and it brings up a program that you now need to tune. It presents the commits in topological order from earliest to latest, and it gives you a set of operations you can do. You can pick a commit, you can reword it, you can edit it, you can fix them up, which means you just squash them together, or you can drop. So what we want to do is that we want to drop this one here. Don't need stinking 11. We're going to squash this one. So let's actually do squash. And let's reword this for fun. So we're actually giving it 3 operations now, where we change the commit message of one commit that we've already made. We mush 2 together, and then we just drop 1. And you can imagine this being very useful when you've already sort of broken you've snapshotted your work 10, 15 times, because this is a difficult feature to get right. And now you want to put those bits and pieces back into order, right? And this would be a good way to do that sort of after the fact, rather than saying, I give up, commit everything in one blob and just call it a day. Okay, so add arc to job name in GitHub Actions. So actions, GitHub kind of implying, and then we have the room to do architecture. Excuse me. Okay, so now we've changed that message, and we're going to see that in the log in a bit. We exit Vim. And this is a squash. So what this does is that it's taken these two commits and just made a single commit of them. The squash and the fix-up, they differ really only by one of them preserving the message and the other one discarding it. In this case, we'll actually manually discard it, and we'll bump the tag at the same time. And you can see there are changes everywhere, both Python and to the wheels, which I think is the tag. Okay. And now, if I do the same log one line, you see the last one, oldest one was add arch to job name. And now we got replace numpy. So we've lost a commit. We've squashed two together, and we added the word architecture over arch. It's pretty neat, right? Excuse me. I do this all the time. So those of you that rebased, is this what you do? You're very quick. Very good. That's a snack. Could you come a bit closer? I don't want to. Very good. Keep at it.
Do it every day.
Wonderful. Do it every day. Okay. So this is something I do all the time. Another thing I do is that let's pretend that this has not actually been merged to master yet. And let's show this one, shall we? So the change here is, do we have a good one? Okay, so let's actually take this commit, but let's not make it Ubuntu 20, it's 22. The file is GitHub workflows, right? So GitHub workflows wheels. By accident, I wrote 20, but I meant for it to be 22, right? Happy with this change? What I can do is I can now add it in patch mode, as you do. And then we see, okay, they're all fine. This is what we want. So yes, we staged this. Git has this thing called commit fixup. You give it a reference. You can, I find generally the easiest way to do this is by actually copying the hash, but there are other workflows you can do. I think in the VS Code, I know Emacs can do it. You can mark the commit and say, mark this as the fixup target. From the command line, this or using the search thing is probably the most ergonomic. Now this creates a regular commit. There's nothing special about this. But the rebase driver knows what this message means. So if you do git rebase, auto squash, interactive, it will now automatically move this commit to where it needs to be in order to fix up. So, and this is very useful. So say you have a commit series of 5 commits, and then you find something later that, that should actually been a part of the second one. You can now just commit it, fix it, mark it, and then forget it, so that when you do run this through your rebase driver, it will automatically sort it out. It's very useful. And if we now do git log 1 line and 5, on the job per arch, this should now have 22 in it, right? Magic. When this is pushed, no one can tell that it ever said 20 there. Okay, that was interactive. And that was fix up. Auto squash you can set in a config to always be there. So let's talk a bit about using histories. We're going to skip the short log, but it's a very brief way, or it's a different format for grouping authors and subjects together. I did want to show off exec. So git rebase exec is, let's do interactive because that makes it very obvious. Head 5 and then exec. Let's just do any fun command you want to run? ls is kind of dull, but we don't have the time to build, so. Tree. I don't have tree. It's too expensive. Let's do ls. So what happens here is that with the -- exec flag, it will insert a command that it will do after every checkout in this rebase process. So now what will happen is that Git will check out each of these commits in sequence, and it will run ls. When you write and quit, it will immediately go, and it, as you can tell, it listed a bunch of stuff. Honestly, not the most appealing demo, but remember, this can now be something like configure and make. And this permits you to actually run the tests for every commit in your series. And remember that every commit should build and test. How do you know that after you've started messing with the history? Maybe you committed without actually verifying that the build worked because you had unstaged changes, so your file tree was dirty and you didn't know that because you didn't check out a clean copy. How can you tell? Well, this is a pretty good way of telling, and it is very automatic. This obviously assumes that your build system is easy to run automatically, which it may or may not be. And if it is not, then I recommend putting in a lot of effort to making it so. Who has bisected before? All right, that's 1, 2, 3, maybe 5. Who has heard of the bisect? It's maybe 15. Okay. Who has found a bug with bisect? 1, 2, 3. Okay. How was it? Did you like it? I mean, it found a bug, so presumably, right? Git bisect is so much more powerful if you have good hygiene, where all commits test and build and have good messages. The reason I spend so much time just yabbing about this is how you write messages or should approach writing messages is to power features like the bisect. I do have a demo on that, but it takes a while to run. So let's do it. So this is GCC. GCC is a popular free software compiler. GCC is pretty big. And because this is a demonstration, or for the demonstration, I've identified a fix and a bug. Now, the fix is, it's applied, so we need to sort of start our bisect, which is a binary search for a bug, where Git basically sequences your tree, and then it does a binary search to test whether or not the bug was present at a certain point, which now gives you the ability to, with a logarithmic complexity, really dissect excuse me, your tree. So it is operated this way. You do a git bisect start, and then you tell Git which commit is bad. Usually that will be your head because you just found your bug, but in this case, I made a tag called last bad for the demonstration. Then I tell Git that bisect good, that releases 12.20 GCC 12. This tag is good. Git computes for a bit. And just to appreciate, let's see, git rev list last bad releases GCC 12. Just to appreciate, oh, hang on, this is not right. We'll do that one after. I did that count before. Never do a live demo, right? I did that beforehand. It's about 9,500 commits in between these two. Okay. So we do a test. So I've written a test script here, which is called GCC test. What it really does is, because this is a demonstration, it checks, does this, is there a pre-built compiler for this revision? If not, configure and make it. Once the compiler is built, try it out and run this specific test here. And then if the bug isn't in there, it will print a red message saying there is a bug. Sorry, otherwise it will say in green text, this is good. So we run our GCC test. Pretend now this is building, but it takes 40 minutes, so it's a bit of a snooze. Okay, so this is good. Okay, so we tell Git that this is good. And now it's here, it cut it in half because it's a binary search, so now we have about 4,700 revisions left, 12 steps. I'm sick of typing, so I'm going to just run the script for every step. And this obviously relies on the compiler building at every checkout, which is why it is highly encouraged. Because if you now need to figure out why, is this now a problem because the build doesn't work, or is this a problem because there is a bug there? It becomes very much harder if the build keeps on failing. And this is going to run for about 3 or 4 minutes, at which point it will spit out a commit with a bug in it. This might seem like magic right now, and quite frankly, bisect is magic, but operating it is very, very simple. Oh, there we have our first bad. We have about 7 steps left. Lovely. The first time I had to bisect, I remember being baffled about how easy it was to do and at what precision I could find the bug. And since then, it's been at least several dozen that I could find. And bug here is a kind of it's an open concept, because bug could mean anything, right? It could be a performance regression, it could be a size ballooning, it could be anything that you can check for with a binary yes or no. So if you can ask your tree, your project, the question, is this something, yes or no, you can use bisect to identify exactly where the problem was introduced. And because we kept our commits small and focused, hopefully we only have a few lines to check, and now we know why this was introduced, so we can have a pretty good idea on how to fix it. It reduces the surface. This is the bug. And if you check the commit that is one after the last bad, it is a fix that references this problem report and this commit. So in between those two revisions on GCC 12 and the last bad, there was about 2.1 million additions and 700,000 deletions into GCC. And we just now narrowed it down to 50, which is a pretty manageable chunk. And it turns out the problem is a spurious return. Bisect alone, I think, should be motivation for why you should have some commit hygiene. We're starting to run out of time, so we're going to blaze past the format patch and send email. Git-log is a lot richer than you think. Not only does it print, the messages you write or did not write, but you can also search on content. So this one, for instance, only selects commits that matches with changes that matches a specific string. So if you're looking for changes that applies to a specific variable or a specific class name or something, this will immediately limit your search. Git grep, Git already knows what files are actual source and what could be generated or not. So git grep is a convenient way to only look through things that are checked in. And if they're not checked in, then, and also to limit that by history. So you can do that at a specific snapshot. with InstaWeb, it's really cool. Now you don't need GitHub anymore, so I just want to show that one off. So git bisect reset, git InstaWeb. InstaWeb is actually really useful when you want to do spelunking. So here, you don't need GitHub anymore. You have InstaWeb. It just allows you to browse the commit, the diffs, but it's built into Git, which is pretty great. Let's see. There we go. Archive allows you to quickly create zips or tarballs. That was it. Please reach out. So this talk is a shorter version of what you should probably attend, which is the workshop. This has been a lot of content in an hour, and it's compressed from 14 to 16 hours. So obviously it's a bit brief. Please reach out. If there are any questions, we have 4 minutes. Interesting questions are rewarded. Thanks very much. Snacks.